Good morning, everybody. Today I'm going to explain you about matter around us. This is a class 9 concept and it is useful for both Telangana and CBSE. Okay. Now see here, matter around us. See, simple. The matter definition you have to remember: anything that occupies space and has weight and has mass. Remember, anything that occupies space and has mass. See, as there is no space here, I am writing here. But see, you can write like this: anything that occupies space. Anything that occupies space. Okay, I'll write here. Anything that occupies space. That occupies. You write occupies. Okay, occupies space and has mass is called as matter. Okay, around us. See, matter exists in all the three states: solids, liquids, and gases. Right now, see, in this lesson, actually, it is an easy lesson actually. But since some students requested, I am saying, as they are afraid of class 9 as it is starting chapter and all. But actually more complicated, more tough topics are there next actually. But anyhow, you just listen. In this chapter you have to learn generally 3 topics. If 3 topics you are thorough, it means that the chapter is done. First one is the properties of solids, liquids, and gases. Okay, means solids will have a definite shape. For example, if I take a duster like this, for example. Okay, see, if I am taking duster, a duster has cuboid shape like that. Okay, and if you take a cylinder shape object, okay, so for example this pen is like a cylinder shape, okay, like that. So shape, okay, what is the shape and all, as whether the solids will have definite shape or not, volume or not, like that. That is about properties of matter. You have to learn. Matter exists in 3 states: solids, liquids, and gases. This topic you have to learn. Then one topic will be there on diffusion. Okay, diffusion means spreading of air molecules from one place to another. For example, I will say you, if you light up a incense stick. Incense stick means agarbatti. If you light it up, what will happen? The smell, the gas molecules will spread from one place to another, one room to another, and thereby we get the smell. In who are sitting in the other room also, they get the smell, or other place at least. Okay, so this property is called as diffusion. Diffusion means the movement of air particles from one place to another is called diffusion. If anybody will ask the reason, because you can say many reasons, like for example, means in many ways you can say the reason. One is due to difference in the pressure in the air molecules, you can say. Okay, another one is due to the different densities of air molecules, like that you can say. That's it. Okay, these are some of the reasons. Right now, coming, see, in biology, diffusion is only also called as osmosis. So in osmosis also, what will happen? Higher concentration to lower concentration, liquids will move, and there we say it as the movement of liquid from one higher concentration to lower concentration through a semi-permeable membrane, like that they will say. Semi-permeable means a light thin layer will be there with some small holes, like that. In that way, what will happen? In some living beings, some liquid will flow like that. That is called as semi-permeable membrane, like that. So it is almost similar. So properties of solid liquid topic, diffusion topic, and evaporation topic. These 3 if you learn, it's done. Now I am going to explain you this. See here, solids have definite shape and definite volume also and all. See, liquids do not have definite shape. Shape means, for example, this is one shape, a cuboid shape. For example, this you take cylinder shape, like that. So that is shape. But liquids do not have any shape. For example, if you want to fill in a beaker like cylinder shape, okay, liquids, if you put, it will get that shape. For example, if you take a conical flask, what is a conical flask is? See, generally in the laboratory, who are studying in the CBSE syllabus or in state also, very good institutions, top institutions, they will have laboratory, they will know what is apparatus meaning is. This is actually conical flask. Okay, so what is happening? If you pour the same liquid, it is occupying the shape of the container, right? So like that. For example, if you pour in the test tube also, what will happen? It will appear the shape of the container. So liquids do not have shape, okay, do not have a particular shape, but whatever the liquid you are pouring, for example, this is 50 ml you are pouring. So 50 ml if you pour, here also it will be 50. If you put a mark, okay, and here also 50. So the volume will remain the same, whatever it is. Okay, so like that. Volume means it's like the space occupied by a substance is called as volume. Okay, the amount otherwise. Okay, right. So what will happen? No. So here first, see what I will do. I don't write shape, volume again. So what you do? Simply you have to remember this. This is first point is about shape. Otherwise you can, if you anyhow in exams etc. you can write. See here, shape. No shape. no shape, no definite shape otherwise, no definite shape, no definite shape. Okay, right. Now, okay, has definite volume. Now when you come to the second point, has definite volume, has definite volume. Okay, same way in the gases and all you can take. See, gases have no definite shape. Yes, why? Because it also occupies the volume, the shape of the container. For example, you are blowing air into any container, for example like this shape, or otherwise in a room, for example, if you take, air will come into the room and the shape of the air has no shape, it is occupying the shape of the room like that. So that is the reason you can take, for example, if you blow air into it, what is happening, this is occupying the shape of the container, so you can say no shape. Okay, and volume. Okay, here actually volume, when you say for the gases, you should say that the volume can be changed, means no particular volume. Why? Because the gases are rigid actually, sorry, compressible. What they are? Compressible. So generally you would say no volume. Okay, or volume changes. Why? Because they are compressible. Gases are compressible, because since you can write since, you can write otherwise, since compressible, since gases are compressible. Now see, coming to the next compressible property. See, you cannot compress a solid generally, except to porous substances like duster, like this sponge. You cannot compress a solid. For example, this is a board, for example, it is made up of, for example, metal or wood, so I cannot shrink it like a duster generally. So generally when you take about a solid, for example, your door might be made up of wood, so it cannot be compressed. So compressibility, solids do not be compressed, but gases, third point, gases can be compressed. And liquids almost no compression, means you can write cannot be compressed, cannot be compressed, cannot compressed generally, means compressibility is very negligible actually, compressed. And here you can say it as no, cannot, cannot be compressed. Here this third one is can be compressed, can be compressed. Okay, so this one. And fourth one, rigid. Okay, so highly rigid, and they are also rigid. Okay, you can say rigid, not highly but rigid you can say. And fourth point here you can say they are not rigid. Okay, properties of matter, when you memorize in the question answers, they may give directly points. So what you do, in order to memorize well, you just write side headings so that you can remember well. Next, diffusion. Actually diffusion means, I said you already, the movement of air molecules or otherwise particles, you can say otherwise. Why? Because liquids also move, so the movement of particles from one place to another place, okay, is called diffusion, you say. What is the reason means, you can say due to change in concentration, due to change in pressure. So liquids or particles move from high pressure to lower pressure, like that you can say. Okay, so no need to say the liquids or gases, in both it will happen. Diffusion generally unnoticeable or does not happen in solids. Liquids and gases, diffusion takes place, remember that. Now coming to the next. So what we are doing is diffusion. Okay, very slowly. You can say here fifth point, diffusion occurs. Okay, occurs, you can say, occurs, you can say, diffusion occurs. Okay, and intermolecular space is very less. Okay, here you can say intermolecular space is more than solids, less than liquids, less than liquids, less than liquids. Okay, like that you can say. And here intermolecular space is more than both solids and liquids, solids and liquids. Okay, now what I am saying is, if the students feel that my video is little fast, I want to finish around 20-25 minutes only, half an hour. Why? Because this lesson does not deserve more than that. But if you want to listen properly, you pause the video and listen, that's it. Now see here, expansion. See, what is the meaning of expansion is, every substance on heating, it will become a little more than more the size or shape than actually it is. For example, if you heat a what you call this any iron rod, etc., before heating and after heating, if you take and measure by using a tape, etc., then it will expand. That is the reason on railway track you can see little gaps they will leave. Railway track, see iron beams when they are joining. Okay, why? Because in summer it will expand, that is the reason. Okay, you can see between iron beams, etc. When I was travel, I was thinking, why they left gaps like that? Okay, but I thought if the gap is more, again the wheel cannot move and it will stuck up and all. But actually then in the higher class I understood, yes, because to allow for expansion only they left. So every substance on heating it will expand. So what will happen, very less means the expansion is very less in solids. But whereas you can write here 7th point, like you can write the side heading like this, expansion and all, like how I wrote. For everything you can write. For now I am not writing, but you can write in exam. For example, if you are writing a test, you can write here these side headings. And why I am making in side headings is, in most of the books, whether you study in any institute, reputed institute, or if you buy any book also, these side headings are not given. So what I am doing is, if this question will come in exam, you just remember the side headings and write in such a way, so that you can easily memorize, and in exam also you can present it in that way, okay, easily. Okay, so like that. So expansion, what will happen, it is more than solids, less than liquid. It is more, means expansion in liquids is more than solids, but less than liquids, okay, that you can write. Now, and one more thing, I am requesting my students, once go through the lesson reading also, because lesson reading also slowly, patiently, for 2 hours you read, enough. Okay, okay, now expansion. So it is more than both solids and liquids. Okay, this you write, enough. Now what we'll do, we'll go to the next topic. This video, whatever I am saying, this video you can pass and you can write, okay, this as an answer. Okay, here also you can write shape and all, you can write. Okay, this video we can you can pass, and whatever the side headings are there, these you write, compressibility and all, and you can do it. Okay, now I am erasing this. I will go to the next topic. See, the next topic will be generally about this diffusion and evaporation. Okay, and before diffusion, I think you have to go with this topic. What I am saying is, what is the definition of this shape I am saying? See, the external form of someone or something is called as shape, and the amount of space occupied by a substance is called as volume. That all I said. And diffusion definition I already said. Effect of temperature on change of state. See, generally when you are okay, bring that, I should erase. Generally when you are heating any substance, what will happen, the state of a substance will change. State means solid, liquid to gas. Okay, means when you increase the temperature. And also one more factor is there, which you got I think in the 8th class, etc., or some other classes you will get in 11th 12th also. Due to increase or decrease in pressure, the gas, for example, you are increasing pressure, a gas will become liquid. And for example, LPG gas cylinder you take. Okay, so in that, actually when you compress it, okay, CNG means actually compressed natural gas. Okay, and LPG is liquefied petroleum gas, means when you compress it, gas will convert into liquid, and even more if you do compression, then it will become solid. So even CO2, so carbon dioxide also, if you compress more, what will happen, under sudden expansion, etc., if you compress like that, there is a property, carbon dioxide will become solid. Okay, so generally what will happen, change of state. See, I am rubbing, you can pause it and write. Okay, these are all points. 6 is about diffusion. Okay, 6 is about diffusion. Diffusion spelling some students will write wrong, DUFFUSION. So S will come only once. Okay, that is the reason I am saying some students will be like that. And intermolecular space, see, intermolecular space has another name also. What is that? Okay, anyhow it's okay, you write here. Okay, done. Now I am rubbing. So intermolecular space means interparticular space, you can say, intermolecular space, but you can say like that, you can say. Okay, molecular or particle, both mean the same, right? See, students who have idea about atoms, they will say atomic space also. Now coming to the next, okay, so what you do is, once go through the lesson reading, and what I am saying is, generally every matter, what will happen, whenever you change the temperature, so when the temperature increases, what will happen, temperature increases, you are right. For example, when you are increasing temperature, what will happen, solid will change to liquid. For example, you take ice cube, ice is becoming water, and water will become, if you go on heating, water will become gas, right? So this is nothing but water vapor, you can say, right? For that they give an experiment also for you. What is the experiment is, generally what they do is they will take in one beaker this ice cubes, and they will be going on heating. Thereby what will happen, you will get like this water, some kind of if you keep a thermometer, for example you are keeping a thermometer inside it, and what you are doing is you are keeping ice cubes, okay, and to hold the thermometer you can use a stand. For example you are using a stand, okay, here you are using some Bunsen burner you can take. For example you are keeping some support here, okay, and you are keeping some Bunsen burner or spirit lamp you are keeping. This is called spirit lamp. Bunsen burner means it will be like a it will be like a, otherwise flame I will keep with red pen. Flame we can keep with red pen so that you can understand. So, okay, support, okay, for example here some support is there to this, okay, like this, okay, and this here there is wire gauge. See, generally these containers cannot be heated directly. What they will do, they will keep one wire gauge, like for example we see for the doors etc, there will be wire gauge so that mosquitoes won't come in that way. Okay, iron gauge will be there, iron mesh you will say, na, that one, like that. So why? Because if you heat any glass container, immediately it will break. Okay. Now if you are keeping ice cubes and go on heating, for example these are all ice cubes, if you go on heating, what will happen, for example the ice cube was at some negative temperature, for example. So if you go on heating, for example -10 something is there, if you go on heating, the temperature in this will be going on increasing. Okay, so temperature, so -5 -2 like that, but when it will reach 0 na, at 0 degree centigrade, though you are supplying lot of flame, means you are supplying heat, but then also there won't be any rise in the temperature of the thermometer. Why? Because the heat is given, okay, means every minute, for example think that from -10 every minute the temperature is decreasing, -9 -8 like, means if you go on heating it is getting heated up and temperature is coming down, means temperature coming down means it means that the temperature is increasing, so it will come until 0. After 0 exactly 1 degree should be there, means for example if you make a scale time, for example first at 0 minute, okay, when you start it is at 10, first minute 9, second minute okay it is 8, for example -8 like that. So like that when you go on coming, okay, 0 1 2 something like that. For example if you take, for example 10 you take, for example 1 2 3, so until 10th minute it should be 0 or something like that, right? So what is happening is at 11th minute 12th minute also it will remain at 0 only. Why? Because the heat given to this ice cubes has been utilized in the conversion of state of matter, means to overcome the interparticular attraction, what it will happen is the heat given has been utilized. This is called as latent heat. Latent heat definition is, okay, the amount of heat required to change the state of matter from solid to liquid, to change the state of matter from solid to liquid, state of matter from solid to liquid, is called as latent heat. See, latent heat of this is actually latent heat of fusion. This is fusion. Another will be there, latent heat of vaporization, that is from liquid to gas, means at boiling point it will become. And what is melting point, means the temperature at which, what is the melting point, the temperature at which solid changes to liquid, means solid changes to liquid is called as melting point, or it is also called as solid changes to liquid, it is also called as freezing point, like that. Okay, done. Now boiling point means the temperature at which, the same way the temperature at which you can write the temperature at which liquid changes to gas, you write, enough, liquid changes to gas. Okay, boiling point I am writing BP, okay, changes to gas you write. Okay, now this is about it. Now we will go to the next one, diffusion. See, generally in diffusion topic this is important. So this is about latent fusion, okay, and the state of a substance changes on two factors. One is what, temperature and pressure. So pressure, whenever pressure increases, what will happen, pressure increases means what will happen, the what you call gas will become liquid and liquid will become gas, that's it, whenever pressure increases, like that. Okay, so this you remember, okay, that's it. And example for the pressure you can say solid CO2 means solid carbon dioxide, that's it. Now we will go with the next one, which one is this diffusion topic. See, if you go on adding potassium permanganate, for example, potassium permanganate means during Holi generally we will take some crystal, okay, like a greenish color crystal. If you put in water, it will give some pink color like that. So some you think like some coloring substance, okay, coloring crystal you are adding. Generally in Holi period, etc., people generally use that generally, and they will put in water. So what will happen, as soon as they put in water, what will happen, it will give a particular color. Generally pink color it will give, right? So what is happening, that pink color will go on spreading, right? This property is called as diffusion, okay? So this property can be explained by using what another experiment, that is on what factors, means what is the rate of diffusion. Generally diffusion means simply you can take like this. For example, take one container, and in the container I will give this diagram also, so that you will understand. For example, you are taking round bottom flask, okay, round bottom flask. I keep another duster ready. Now see here, a sponge. See, for example, this is a round bottom flask. Okay, this is a round bottom flask. What I will do is I will keep some kind of crystal in it. See, means you are adding some crystal. So this is liquid is there. Okay, what will happen? For example, this is liquid. As soon as you add some crystals, for example, you are adding some green color crystals. Okay, let us put green color only. Okay. See, for example, this is a green color, right? So right now done. What is happening now? The green color crystal will get converted into some kind of liquid, and it will spread color. It will spread throughout the liquid. So thereby you can say that the spreading of the particles in, okay, one substance to another is called as diffusion. That's it. So generally, in synthetic example, air is spreading in the air only, but here what is happening, the particle, solid particle is spreading in the water, like that. This is also one kind of diffusion also. Okay, it may happen air to water, water to air to air, like that. Okay, done. Now we will go to the next topic. Actually, what is rate of diffusion? Means the topic is diffusion of two gases. See, generally you have to take one glass tube, means like tubelet. See how you have tubelet in the form of cylinder, in the same way you have to take a glass tube which is 1 meter long. Okay, so there are, means it means that there should be markings on the glass tube. Otherwise, you have to only take a scale and measure. Now, what you do, you keep HCl and also NH3, cotton plugs. What is the meaning of cotton plug is, you know very well, some cotton you can take and you have to soak it in both, one is in the, you can say it as HCl, means hydrochloric acid. And here you can say another cotton plug you keep, means cotton plug means some cotton quantity. You can keep it in the what do you call, ammonia. You can keep it in the ammonia and soak it. Then what you do, you keep okay, a cork. Cork means like rubber stopper. So thereby you are not allowing the outside air to come inside it. That is the meaning. Okay, now see what will happen when these two substances combine. Okay, I will give the reaction. HCl will combine with ammonia. Actually, what will happen? NH4Cl, means ammonium chloride will be formed. This is called as ammonium chloride. What is that? Ammonium chloride. So now the point is, here this experiment is given. See, this experiment is given to say the process of diffusion. Means molecules, particles move from one place to another place. But this experiment is given, out of these two, which one will go faster? Actually, ammonia has a mass of around 17, see, think that some 17 grams like that in your language. Okay, because you don't know about this how to measure mass and all, and this will be around 36.5, means like 37 approximately. 36.5 approximately, you can take it as like 37. So what is happening, this is heavier, okay, this is lighter, 17 is very less number. So what will happen, this ring will be formed a little nearer, means a white color ring will be formed a little nearer to water, nearer to HCl than NH3, means because NH3 is lighter, it will travel longer distance. So thereby, so you can say that rate of diffusion, there will be formula in the regular Telangana syllabus, they are giving, not giving. For example, this you take it as first substance, second substance, anything you take. For example, otherwise we will take like this. Ammonia you take, okay, ammonia has less what do you call, diffuses more. Why? Because its mass is, you can take like this. Ammonia, the rate of diffusion is inversely proportional to mass, means more the mass, less the rate of diffusion. So if less the mass, more the diffusion, means inverse, means if this is increasing, then this will decrease, like that. This is called inverse. So NH3 and HCl if you take, what will happen, it will become like this. Actually under root also will be taken based on some calculation, and thing is here HCl will come up and mass of NH3 will come down. Means since mass of ammonia is lesser, then the rate of diffusion of ammonia is more, like that. Inverse means because it is small number you are getting, this will be means this is a small number, means this is decreasing. So what is happening, this rate of diffusion of ammonia is more. Okay, so increasing, you can write increases, it is decreases, like that. Okay, inverse proportion, like that. Why? Because 17 is smaller than this one. Okay, means simply if I want to say, if the substance is lighter, then it will travel more distance, that's it. Simply if you want to know, that's it. Okay, means less the mass, more the distance it travels, that's it. Okay, simply you can take it and you can use this formula, otherwise it is inverse proportion relation, and if you want you can keep root, means for exact 100% correct formula, correct root, like that. Okay, this is about the experiment, simple, that's it. Okay, to explain about the experiment, first of all you write the aim of the experiment: to observe the speed of diffusion of two gases. What is the aim? You write to observe the speed of diffusion of two gases, and then you write apparatus. Anyhow, you know very well what are the materials required. I said you long glass tube, okay, of 1 meter long, and what you have to do, liquid ammonia, hydrochloric acid you have to take, and pieces of cotton you have to take, and you have to take this tongs. By using tongs you have to hold it, and you have to take cocks, like that, and explain whatever the experiment I said. Okay, observe for a few minutes. After few minutes you will notice that this a white color ring will be formed. This white ring formation indicates that the formation of ammonium chloride. Okay, so by this we can say that the diffusion of ammonia is faster than hydrochloric acid, like that you can say. Done. Now I want to finish the video a little within few minutes, so that's the reason I am going a little if you want you can go pause the video and listen properly and go through textbook reading once. Okay, now last topic but not the least but very important, what is that, is evaporation. See, evaporation actually most of the students will confuse. I'll make it very simplifier. See, generally you know very well, when you boil, the liquid moves vigorously, all the molecules. Okay, that time what will happen, the liquid will change to gas. But in evaporation is also changing from liquid to gas, but that is not a vigorous process, understand. So how generally evaporation takes place is, for example you take a lake or river, like that. Okay, so for example think that this is a river. So in the river, the upper surface of water will absorb the heat of the sun. For example, sunlight is falling on the upper surface. So here the molecules, what will happen, these molecules will absorb that heat, okay, so by sun rays, etc. Okay, and these molecules will get enough heat energy and they vibrate more, and thereby this water molecule will change to gas. So what is happening, this process of evaporation is happening over the surface of the liquid, and thereby what will happen, now this upper layer of the water is going changing into vapor, na? So now this second layer will become the upper layer, like that. So this evaporation is the, what you can say, evaporation is the evaporation. So when you write about evaporation, this evaporation is a slow process actually. Okay, you can write the definition and all. Even I too wrote the evaporation. The phenomenon of change of liquid into vapors at any temperature below the boiling point. What is evaporation? The phenomenon of change of liquid to gas at any temperature. The phenomena of changing a liquid to gas. A liquid to see now evaporation, the phenomenon of changing of a liquid state of a substance to a gas state at any temperature below its boiling point is called as evaporation. See, evaporation on what factors it depends, means there are three factors. Okay, factors on which evaporation depends: surface area, humidity and wind speed. See here, whenever there is a surface area, for example I am taking in a glass container some water, and if I keep in the water in the glass only, it won't evaporate faster. But if I throw that water on the floor, what will happen, easily it will evaporate. Means it means that if you are increasing area, evaporation increases. Means when surface area increases, you can write in the exam like this: when surface area increases. Okay, for example I'll write like this here: when surface area increases, when surface area increases, okay, increases. Okay, when surface area increases, what will happen? When surface area increases, evaporation also increases, you can say, right? Now humidity. Humidity, see, generally when humidity increases, means generally what is meaning of humidity is the amount of moisture present in the air, in our surroundings, in our atmosphere. If if air already has more amount of humidity, then what will happen, it cannot the water present there, the river water present, etc., some water present, the it won't evaporate, so evaporation decreases, you can write. And now see, generally wet cloths, when you keep it on dry, okay, outside by using any rope, etc., when you dry up, what will happen, if the wind is flowing more, what will happen, if the wind speed increases, evaporation also increases. Why? Because from the cloth, generally cloths are porous actually, means there will be small tiny holes where water droplets will be there. If wind is flowing more, what will happen, it can carry out all the liquid, and thereby it means that evaporation is taking place faster, like that, okay. And when you sweat also, actually what will happen, that is the reason in summer you have to drink more water to keep your body cool. See, in sweating also what will happen, the water present in your body will absorb the heat from your body and it evaporates, so you have to drink more water, like that, okay, that you remember. And see, there is some experiments given to show how small the particles are. So if you take 2 crystals of potassium permanganate and add in 90 ml of water, then take from this some 10 ml of, again you take some this liquid and add to this 10 ml, then what will happen, the color will be more thicker and it will become red. Now means it is already 10 ml only mixed in 90 ml water, again you take from this 10 ml, means it is getting diluted, means color is getting decreased, like that. So that's it, but it means that 2 crystals of potassium carbonate contains more water, okay. Thank you. Once read textbook, and if at all you have anything like that, workbook or anything, once go through, that's it, okay. These are about the topics, easy only, once go through that. Thank you everybody.